Okay, welcome everyone, and thank you for joining us for today's webinar, Integrating Terraform with OSS Spinnaker. My name is Bo Roberts. I run marketing at OpsumX, and I'll be the host for the webinar today. Just a few announcements before we get started. If you have any questions during the presentation, please type them into the question box in the Zoom control panel, which you can find down at the bottom of the window. We'll address any questions during the presentation that are appropriate, but most of them we'll handle during the Q&A session at the end of the presentation. We'll also be asking several poll questions during the webinar today. These are questions that we ask to give our presenter, an idea of who's in the audience so they can sort of adapt the presentation a bit to who's in the audience. And these questions are completely optional, but if you can answer them, that would be appreciated. And we'll share the poll results with you when appropriate. Okay, let's get started now. Okay, there we go. Okay. For those of you who may be new to OpsumX, just a little bit about us. We're a venture-backed startup based in Silicon Valley. We help enterprise organizations modernize and transform their software delivery with Spinnaker. We provide an enterprise-ready distribution of Spinnaker called Open Enterprise Spinnaker. We also provide managed Spinnaker as a service, as well as Spinnaker onboarding, training, and support services to help enterprises adopt and scale continuous delivery in Spinnaker in their organizations. So just a little bit about us before we begin. And now, before we start the presentation, I'd like to do a couple of those poll questions that I just mentioned. I'm going to put those up, which you can answer on the screen. And there we go. So the first question is, are you currently doing continuous delivery? And if yes, with what percentage of your production applications? And the second question is your organization currently evaluating or using Spinnaker? So if you wouldn't mind answering that question or those questions, that'll give us an idea of who's in the audience and what you guys are doing with continuous delivery in Spinnaker, and help our presenter kind of customize and tailor the presentation a bit. So, okay, we've got people answering, and got still people are answering. So if you'd like to answer the questions, just do that now. I'm going to give it a few more seconds, and then we'll wrap it up. Okay. Thank you, everybody. We've got a bunch of people who have answered. I'm going to give it a few more seconds, and then we will end this poll. So there we go. Okay, I'm going to end this in 3, 2, 1. There we go. And as I promised, I'll share the results with you guys. So it looks like we've got a good mix of people here who are doing continuous delivery at different stages of their journey here, and then also people who are using Spinnaker, not using Spinnaker. So that's good to see. Okay, we're going to put that away. And now we'll move on. So now I'm going to turn it over to today's speaker, who's Anup Thadapalli. Anup, I'm going to turn it over to you now.
Thank you, Bob. I appreciate it. Hello, everybody. Good morning, good afternoon, good evening. So, as Bo mentioned, today's topic is quite interesting. It's more about integrating Terraform with open source Spinnaker. So before we start off with the Terraform integration process and how the Terraform functions, so I would like to give a brief introduction about how the current enterprises are transforming and adapting for faster release process, and in that process, what are the challenges that organizations are facing. So As most of you are already aware, enterprises are really are really adapting faster release process by increasing adoption of public cloud and containers, and by transforming their applications into microservices, which is again basically to uh, deliver the product into the market with hourly or daily releases. So in this process, most of us might be using multiple CI/CD tools, and some of the challenges which I have personally faced is basically to maintain custom scripts for cloud on a multi-cloud deployments, and this is a challenge because either, let's say, if there is any issue and you have to roll back, or during the manual verification there is a issue, and for you to hand over the custom scripts to a different user, you need a human. We basically need a person to do the knowledge transfer. So basically, there are a couple of challenges involved in it, and not only the custom scripts but also manual verification, which is a error-prone process, because we might in most of the use cases we might pick up those bugs which is already tested, or which are simpler use cases. So, or we might miss few major items while testing. And some of the time consuming aspects, like approvals or manual approvals, rollouts and rollbacks of your deployments in case of failure. So these are other time consuming factors. And along with this, ensuring compliance and enforcing policies as per your requirement to maintain service level agreement of your release is quite a challenge. So considering all this, we at OpsMix, we have come up with a we have come up by applying all the best practices. We have found that Spinnaker is best tool for the CI/CD challenges. And to give a brief introduction about Spinnaker, so for some of who are not aware, so Spinnaker is initially developed in Netflix, and it's battle tested at Netflix on their production environment, where there are around 7,000 plus applications and about 8 to 9,000 deployments on a day-to-day basis on their production. So with that kind of a battle testing product, Netflix has outsourced the product as an open source in 2015. And since then, Spinnaker is backed by major tech giants like Google, Amazon, Pivotal, Microsoft. There's a huge community out there who are contributing Spinnaker on resolving issues, basically contributing for multiple requirements. So from OpsMix, we ourselves, we have contributed and spent and fixed around 600 plus contributions from our end. So Spinnaker, as I've told, Spinnaker is a open source, a multi-cloud continuous delivery platform, which is basically developed with keeping high velocity deployments with confidence in mind. And this is designed with pluggability in mind. You can you can add in any tools that you're using in the current any CI tools, or basically any tools that is available. You can integrate it with Spinnaker, and you can just continue using it. And since I've already told, it's a multi-cloud tool. Spinnaker is supported by almost all the cloud providers right now, like Google Cloud, Azure, AWS, OpenStack, Kubernetes, Oracle Cloud, And in fact, if you want to install Spinnaker on a proxy service, which is behind your network, you can go ahead and install that as well. But there's quite a challenge in that because it's proxy based networks. The installation process differs from how we install it on the cloud. And pipeline, creating deployment pipelines and integration and system tests, that makes Spinnaker makes it pretty easy for you by triggering pipelines via Git events, Jenkins, or Travis CI, Docker, or any other pipeline, Spinnaker pipeline process that you wanted to use. And immutable images is what makes it more interesting. So let's say you're using AWS and you want to create an image and deploy it as an as a EC2 instance. Deploy your application into EC2 instance. So Spinnaker uses Packer as a baking service right now. So it basically bakes your artifacts into an AMI, creates and deploys immutable images for faster rollouts or rollbacks in the process of eliminating, your debug configurations and drift issues. And as I've told you, the community for Spinnaker is quite a huge. There's a Slack channel you can join in from spinnaker.io. There are 9,000 plus users who are actively discussing about Spinnaker issues on a day-to-day basis. So what makes Spinnaker special? And we have so many other CI tools, CI/CD tools available, but what makes Spinnaker special? So a couple of features that is like Spinnaker has inbuilt pipeline strategies like red, black, blue, green pipeline strategies, which makes your production deployments seamless production deployments. And this is basically built for high velocity deployments. Spinnaker is based on Spinnaker itself is a multi-service tool. It has multi-services in Spinnaker. So this is built with high velocity to deploy faster and often. And flexible pipeline management makes it easy for users to understand the pipeline strategy, simple and straightforward. And as I've already told you, integrating with all the major cloud providers, and this supports both on-prem and Kubernetes. So in fact, if you want to integrate any of your cloud platforms like Azure, AWS, Oracle Cloud, GCP, anything can be integrated with Spinnaker. You can deploy you can create your instances using Spinnaker, and you can create Kubernetes clusters using Spinnaker. So basically, there are multiple things that you can play around with Spinnaker. And coming to the CI integration, currently Spinnaker supports Jenkins, Travis CI, Circle CI, and CLI. Spinnaker has a command line interface, which basically allows you to templatize your pipelines and replicate the similar pipelines into multiple other environments. And coming to monitoring and integration, Spinnaker already by default, it supports Datadog, AppDynamics, Prometheus, Grafana. In fact, if you want to add on some of the monitoring tools like Nagios or anything, that can be custom based, but you can integrate all of those monitoring tools as well. So with role-based access control, you can basically control access within your team, wherein so for example, you have a development team, a QA team, and a team who can approve your deployments and production. All of this can be controlled via role-based access. and which can be done from the Spinnaker UI itself. You can provide the access from the Spinnaker UI itself according to the groups that you want to provide access. And notifications and manual judgment. Manual judgment is one of the stage which allows you to approve, to proceed the to promote the deployments for the further environments, for any other environments like your UAT production or any other environments. And Chaos Monkey. So this Chaos Monkey integration. So this basically allows you to, keep your production basically keep your production stable in any kind of issues that your production run into. Basically, Chaos Monkey ensures that your production is a resiliency test proof environment in case of any hurdles, in case if your production run into any hurdles. And with that, I would like to introduce you to the Spinnaker architecture. As I've mentioned, Spinnaker consists of number of individual components. Like there are major. Basically, Spinnaker consists of multiple services, like Deck, that is the UI to access Spinnaker, and Gate manages all the API calls. Orca is basically the orchestration engine for Spinnaker, which is responsible for pipeline and other operations. So Cloud Driver is where basically you configure all your cloud providers like AWS, Azure, Kubernetes, and so on. Front 50 is where we configure all of your storage details, which holds the metadata of your pipeline, notifications, application. Basically, all of the Spinnaker metadata will be passed through Front 50, and it will be stored in your relevant buckets, let it be S3, GCS, or in fact, if you're using Minio, it can go through Minio also. And Roscoe is what I have mentioned about immutable images. So Roscoe takes care of baking immutable images. It's not only relevant to AWS Azure, in case if you're trying to bake something through Kubernetes. So for baking, basically, if you want to bake your products from any services, Roscoe is one of the major components that is used there. And Igor is responsible to handle your CI integrations, to trigger pipelines or integrating your CI like Jenkins, Travis CI, or any of those integrations is handled by Igor. And Echo is the event bus engine, which basically sends the notifications via Spinnaker. If you configure SMS, it goes to it gets in as a message, or email, or Slack notifications. And in case if you want any custom stages like WebEx Teams, so that can be set up as a custom notification. But yeah, so basically for notification triggers, Echo is what is responsible. And Fiat is your authorization engine. Basically allows users, so for a role-based access control, Fiat plays a major role. And if you are keen on utilizing Canary analysis, Canta is responsible for Canary analysis. It basically rolls out your metric details of your deployments on the score detail, depending upon the requirements of your scores. Overall, Spinnaker comes up as a service when Halyard is available. So Halyard is the configuration tool, which is basically a CLI based, that can update all the configurations to Spinnaker via Halyard. So this is a brief diagram about the Spinnaker structure of how it looks and how the request passes. As you see, Gate plays a major role communicating to all the services that is available in Spinnaker. Excuse me. So there are a couple of methods that is available to install Spinnaker. So if you're planning to just evaluate Spinnaker, the best approach is for you to have a standalone, which is again not a production recommendation. So it can be installed on a single VM, and you can just play around with Spinnaker. And if you're planning for a distributed Spinnaker, you can basically install a distributed Spinnaker, which is totally container based. You can install on a Kubernetes cluster, on a vanilla Kubernetes cluster, or a OpenShift EKS cluster, GKE, AKS, or a Oracle Kubernetes service. So basically any of the Kubernetes clusters, you can install Spinnaker. And Helm installation, you have there is a documentation available on our website. If you visit blog.opsmix.com, we have provided the instructions to install Spinnaker using Helm charts. So you can download the stable Helm chart that is available on the internet and just go ahead and install. And operator. So we from OpsMix, we have Spinnaker operators on both operatorhub.io as well as a Red Hat certified operator, which is available only on OpenShift. So this is again a simple install process. All you got to do is pick up the operator and install. You can install on a standalone on a single noded Kubernetes cluster or on a multi-noded Kubernetes cluster. So similar with the OpenShift also, you can install it on an OpenShift cluster also. So with that, I'll move on to Terraform and a basic overview of Terraform. So I assume most of you are already familiar with Terraform. Terraform is a tool which is a multi-cloud tool similar to Spinnaker, and Terraform is it's a completely declarative tool. You can declare whatever your requirements, you can declare in your plan, and you can just execute the plan. Once the plan is initialized and applied, and all of your options, what you choose to execute, it can go ahead and execute the details as how you declare. So this is basically widely used to build change and version control of your infrastructure. And similar to Spinnaker, as I've mentioned already, similar to Spinnaker, Terraform is also a multi-cloud tool. Some of the key features of Terraform are infrastructure. It's infrastructure as code, where using a high-level configuration syntax, you can create your infrastructure on a data center to be versioned and treated as you need. And execution of plans. So it's Terraform is all about planning a step where it generates an execution plan, and your plan shows what Terraform will do when the plan is applied. And the resource graph allows you to build the graph of all your resources, and parallelizes the creation and modification of non-dependent resources. So change automation, this is again, it's nothing but in case if you have any complex change sets that can be applied to your infrastructure with minimal human interaction. These are some differences which I've identified from between Terraform and Spinnaker. So Terraform is majorly used for infrastructure provisioning, whereas when I say infrastructure provisioning, this has become most popular in providing in the manage of managing your infrastructure and managing software deployment process and everything. But the only difference is Spinnaker has but the only difference from this is Spinnaker offers built-in support for creating load balancers, resizing your clusters, or rollbacks, and approvals of your deployments. So basically everything can be seen on a UI and manage your deployments as how it is required. And with infrastructure as a code approach, Terraform provide effective, reusable, and safe infrastructure provisioning automation. And as I've already mentioned, Spinnaker has inbuilt deployment strategies like red, black, or blue, green, and Highlander. So red, black is nothing but it basically controls the downtime of your production by once your new deployment, a new version of your release is pushed into production, until the latest deployment is healthy and stabilized. Spinnaker will ensure that your previous version of deployment is active. And once the latest version of deployment is active, the previous deployment will not completely get removed. It will just be disabled. In case if you find any issues, all you can do is you can just go ahead to the deployment and roll back. It will delete your your latest version, and the previous version of deployment will be back within a fraction of seconds. And as I've mentioned, Terraform and Spinnaker both are a multi-cloud deployment, a multi-cloud tools, which can be which is basically supported on any cloud providers like Google Cloud, AWS, Azure, Kubernetes. And Terraform and Spinnaker are complementary together. Spinnaker can be used alongside Terraform in cases where either Spinnaker doesn't have native support like bare metal provisioning, or Terraform is used as a provisioning tool where Spinnaker is used as a deployment tool. So the Terraform scripts can be promoted to production, and where mostly manual handovers, where most of your manual handovers are done. So instead of the manual handovers, you can basically use Spinnaker as a platform and just walk through the pipeline, which can ensure that the human intervention is minimalized with Terraform and Spinnaker together. So this is the document that you can find the best practices of Terraform with Spinnaker. I'll walk you through a document on how to integrate Terraform with Spinnaker. But before the document walkthrough, I would like to give a small demo of the pipeline structure that I have created with integrating Terraform with Spinnaker. So this is just a simple pipeline where it creates a Azure Kubernetes, Azure managed Kubernetes on the Azure, and deploys an application, and finally it will go ahead and destroy the cluster. So for this, there are a couple of mandatory fields. So let me first go ahead and execute the pipeline, and while the pipeline is getting executed, I can walk you through how this goes. So yeah, right now we see the pipeline is getting executed. This is going to take some time. I mean, if I'm not wrong, it's going to take an hour time for the pipeline to complete. So while it is executing, I'll show you the output of how it gets generated. So when your plan is getting initiated, you can see the console output of the plan right here, where it calls the Terraform service. We from OpsMix, we have built a custom service that supports Spinnaker. So, but you can access the with the help of the documentation that's available on the internet. You will be able to configure it to your Spinnaker. If you're using the open source Spinnaker, it's pretty much open to open for you to configure it. So that should not be a problem. And once your pipeline is started, you can see the Terraform plan output here, where it will initially, call for a apply, and in this process, you can look out for the resource group name. This is the resource group name that it gets created in the Azure, and this will be the cluster name that I'll be creating it. And once the resource group name, everything is called out and it's successfully done, it completes the plan and it generates a plan output URL. It will be stored in my dynamic accounts in the GitHub. So I'll show you how the dynamic accounts and all of those are working while the pipeline is executed. And once at the end of the pipeline, you'll be able to see the output that, once the plan job is done, it'll pass on for Terraform apply. That will subsequently run after this. And here I have a manual judgment, which will basically ask for an approve or a reject. In case if I see any failures here in the output, if I don't see my cluster name or anything, I can just reject here and make changes accordingly in the GitHub. So once everything goes good here, all I have to do is approve, and it pushes on the stage to a next cycle. That is the planned apply job. And in this job, what it does is, as you see here, it will communicate for the artifact account, that is the GitHub artifact account, and the state repo is where all of my Terraform configurations will pick it up from. And in the console output, you can see that when we scroll down to the plan Terraform apply output, you'll be able to see that the location of the cluster getting created and the name of the environment and the resource group names. So once at the end of the plan, you'll be able to see the node count, how many nodes is assigned to the cluster, and the size of the VM in the same, everything can be seen in the same UI. You don't have to juggle between your Azure UI and then Spinnaker UI. You can see basically almost everything in the same Spinnaker UI. And at the end of the deployment, at the end of the stage, you'll be able to see the cluster name is getting created with a demo environment. And after this, you'll again have a manual judgment. This is because for you to ensure that your cluster is created as how you declared in your configurations that you have declared in the Terraform plan. So once you verify all of those, you can just approve it. And once the approval is done, it will proceed with the deployment. So right now, I'm just using a basic YAML that allows a simple application I have. As you see, I have a very simple application, and it'll just deploy this application into the Kubernetes. And again, you might have this question: how does this particular deploy stage know how to pick up the right Kubernetes account? So I have the account hard coded here as part of the stage. So this is a conditional expression that I pass. And for this particular stage, it will pick up the Kubernetes cluster name that is created in the apply job that is in the previous stage. And once that is done, it will, as of now, it will go ahead and deploy the application for a default namespace. But in case if you prefer to have any other namespaces, in the apply job, you can create the namespace, and here you can override the namespace and push it accordingly. And at the end, so once your deployment is done here, at the end, again, you'll ask, it'll ask for a user validation, which is again basically for you to ensure that your deployment is done successfully and validate your application deployments and anything. And if you want to keep the cluster active for some more time to do your validation, you can just keep it active. Or else if you see all of your testing is done successfully, and for cost optimization, the best thing that I have gone through is to destroy the job. So once you click on approve here, it just goes ahead to the next stage and destroys your cluster in the Azure. Or else if you go ahead and reject in this stage, it will just keep your cluster active for how long ever you want the cluster to be active. And then you'll have to go to the Azure and delete the cluster manually. So this is how the stage works. And manually, I'd like to show what are the jobs, what are the stages that we add right now. So that part I can walk you through in the documentation that I have here right now. So you can access docs.opsmix.com, and under code labs, you have Terraform custom job in Spinnaker. So these are the configuration steps. It shows Git username, but this particular Terraform service is basically you can access through S3, GitHub, or there's a testing going on for other source code management as well. So as and when everything is like a GCS, in case if you're planning to store your Terraform plans in GCS or anything. So all of those are still not tested completely from our end, but currently we have GitHub, S3, Bitbucket supported completely. It's tested from our end, and we have given the artifacts JSON. So this artifact JSON is nothing but you need to, wherever you have your Terraform plans configured it, like let's say at GitHub, Bitbucket, or S3, you need to provide those credentials here, and then so you can download this file in your onto your environment and follow the instructions provided in this document. So you need to download that file, provide the credentials, and then pass it through Spinnaker. And for you to see Terraform stages are not inbuilt in Spinnaker. These are custom stages. So for you to see Terraform stages in Spinnaker, you have Orca local.yaml available here. You can download it, and you need to create that file in the location that is mentioned here. If you're using a local Debian Spinnaker, that is a standalone Spinnaker, you need to create this file in the server where your Halyard is installed. If you're using a container-based Halyard, you need to get into your Halyard container and go to profiles and place this file accordingly. There are quite a few changes that you might have to do here, like the namespace. So like the application name that you're configuring, and the namespace and all that. So those are the changes. There are only 2 to 3 changes that is mandatory here. Apart from that, rest of them you can just use it as it is. So once you have these and you do a hal deploy apply, which is nothing but restarting Spinnaker, you'll be able to see the Terraform plan job, Terraform apply and destroy job on the Spinnaker UI as how you see here. So once you have these stages available, there are a few mandatory fields for you to fill it up in the Spinnaker. Like, for example, your Terraform repository details. I can show you on my pipeline here. So these are the mandatory fields that so the artifact account, which you will configure in the artifact account.json, and the location of where your Terraform plan is stored at, and the state repo of all the basically this is where this is the home repo of your Terraform plan is located. And the user ID, it can be unique user ID, and you can give it anything you want. There is no restrictions for the user ID. So, and this keeps changing for every stage. For Terraform plan job, you need Terraform plan mandatory of what you're trying to create. In this scenario, I'm trying to create a Kubernetes cluster for Azure. So if you're trying to create an AWS instance, you can go ahead and declare that that particular plan over here. And in the apply job, all it does is apply job is completely dependent on your Terraform plan job. Once your Terraform plan job gives an output URL for apply, it will just go ahead and create a Kubernetes cluster in that particular account as what you have declared there. And apply job only requires these three details: the artifact account, state repo, and the UI user ID. This should remain same for each and every stage going on. So apply job and destroy job, you should have the same details. There should not be any changes in that. So yeah, so that's pretty much about the demo I have. And as I've mentioned about the plan details. So these are the plans. This is the plan. This is where my Terraform plans are created right now. If you see, I have multiple things saved here. AWS is to create VPC or an EC2 instance and a EKS cluster. And GCP, I create a GKE cluster here, or in fact, you can create a instance also. I haven't saved the details here, but yeah, you can create a Google Cloud instance as well. So Azure right now, I have only tested creating the K8 cluster. As I've mentioned, let me just walk you through how the configurations are done here. Sorry, it's the wrong file. So this is where our plan configuration is saved at. When dynamic account, there will be a file which gets updated. And once that is done, it will put only, and it the stages are dependent based on the job on the first stage, on the plan job stage. Once if your plan job is successfully executed, only then the request will pass on to the next stages. So with this, my demo is done. You have the for any Spinnaker tutorials that you have that you need, you can clone this tutorial, and you can basically access all of the tutorials that is available on the GitHub. So the Terraform document, the Terraform stage that I have walked you through now, you can access the document from this particular best practices link available. And as I've mentioned, in case if you want to reach out to us, you can reach out to us from the Slack support by registering yourself into Spinnaker team slack.com. Also, you can drop in a direct email to hello@opsmix.com if you need any other information, any more information about our discussion today. So with that, Bo, I'd like to hand it over to you.
Okay, great. Thanks, Anoop. That was really good. Yeah, so what we're going to do right now is we're going to move on to the Q&A. So if you have any questions for Anoop that you'd like him to answer, please submit those right now using the Q&A. There's a little button with Q&A down at the bottom of the Zoom window. So please do that now. Before we do that, however, I've got one more poll question I'd like to ask, and this is basically the way that we sort of coordinate how we send people the presentation slides. Oftentimes we get people who would like to be sent the presentation slides, and we don't post them publicly, but we're happy to send them to you after the webinar. So I'm going to launch a poll question now. And then I wanted to just point out a couple other things that if you would like us to follow up with you about, we can follow up with you about these. So first thing is Spinnaker training, onboarding, or support. We offer those services, and we're happy to kind of follow up with you if you're interested in learning more about that. We can also schedule a demo with you for OpsMX Open Enterprise Spinnaker, which is our enterprise-ready Spinnaker distribution. We also have managed Spinnaker and Spinnaker as a service. We can demo any of those for you. Another thing that we can follow up with you about is we offer what's called a complimentary sort of continuous delivery strategy workshop, which is like a 2-hour Zoom session where we get on a Zoom session with you or your team and kind of walk you through sort of a planning framework around continuous delivery and Spinnaker. So if you would like us to follow up with you about any of these things, you can just select that on the poll, and I'll leave that up there for a few more minutes to let everybody respond if they want to. And now let's move on to the Q&A. And let me, okay, so Anoop, the first question we've got is, if we install Spinnaker via Helm, then how can we pass the JSON key for another cluster and GCR registry communication? That's, hope that was clear. That's the way it was written.
Yeah. So basically, any JSON key that you wanted to add from related to I mean, in process of configuring it with Spinnaker, there are configuration steps available. So it's basically just a couple of commands that is needed. So once you execute the commands on the Halyard container, so when you install it via using Helm charts, your Halyard configuration also gets created as a container. So you need to log into the container and update all your settings as how you need. But the one risk factor is when your Halyard container gets terminated, these settings might get reset back. For that purpose, we are configuring a dynamic accounts, external dynamic accounts. Basically, all your settings will be stored in that dynamic account. And so basically, if there is any crash in the container, your configurations will still be safe in your dynamic account in GitHub, Bitbucket, or any place. Once your container is back, it will just revert back from that place where you configured it. Hope that answers it.
Okay. All right. Next question is, let's see, do Terraform stages show up in Spinnaker by default?
Not really. As I'm walking through the document, this is a custom stage, so you'll have to add the stages with using the orca local.yaml provided in the document. So once you have that set up, only then this can be, I mean, this will reflect on the Spinnaker UI, or else there are no chances of it showing up by default.
Okay, let's see, I just want to let everyone know, yeah, if you have any questions, please type them in now. We've got a couple more, but we're quickly kind of coming to the end of the hour, and I want to make sure we get in as many questions as we can. Okay, so Anoop, the next question is, can we use Spinnaker to manage app operators like Prometheus operator?
Yes, we can.
Okay.
Yeah.
All right. Next question is, what are all of the infrastructures that can be maintained by using Terraform and Spinnaker?
So if you want to maintain infrastructure only with Spinnaker, it's basically limited only with AWS, Azure, basically all the cloud providers. But when we integrate Terraform with Spinnaker, it allows you to basically manage almost all the infrastructures, including your bare metal servers. So you can manage almost any kind of infrastructure using Terraform with Spinnaker.
Okay. Okay, now another question. Can we have multiple versions of Terraform running the Terraform Spinnaker? If yes, how can we run multiple versions on TerraSpin pod?
So right now, the TerraSpin service, it is just a one single version that we have configured. But yes, Terraform you can configure any versions. But the only difference is you'll have to provide your plan details on the artifact accounts.json that we have documented. So that is where all your plans will get picked up from, and it will be sent to Spinnaker. So that is the only difference. But yes, you can use any version of Terraform with the TerraSpin service. The service can handle it basically.
Okay, great. Okay, so we've got another question that just came in. So let me get to that. And okay, so question is, I know this is a Terraform demo, but can we deploy Helm applications from inside Spinnaker, like running Docker in Docker for Jenkins in Kubernetes?
Yes, we can. So for this particular scenario, I mean, as how I think most of you remember, we spoke about Helm. Basically, it bakes all of your images in the Helm stage. I mean, when you add when you're trying to deploy using your Helm charts via Spinnaker, and once all of your I mean, once the bake is done, it'll convert. Packer will convert that Helm chart into an image, a Kubernetes compatible image or a Docker compatible image, and it will push into the deploy stage. So yes, it is possible. We can deploy applications from Spinnaker using Helm stage.
Okay. All right, one more question. I have a Terraform file for multiple resources. Can I deny the resources at the time of runtime? Let's see, I have EC2, S3, RDS, all of that. I have created pipelines at the last moment. I don't want to create EC2. Is that can be done via Spinnaker? Sorry, that's
yeah.
Let me know if you need to.
Yeah, I think I need to. I need more context on this part because it's.
Okay.
Yeah.
Okay. Yeah. So maybe you can follow up with this person after the.
Yes. Yeah.
Okay.
We'll do that. We'll do a follow up.
Okay. All right. Thank you for that question. Anoop's going to follow up with you after the webinar to answer that. Okay. Let's see. If you have any other quickly kind of coming to the end of the hour. If you have any other questions, please type them in now. We've had a lot of great questions today, which is good. And then getting back to this poll question, I've left this up, but just wanted to give you one last chance. If anybody would like to be sent the presentation slides or would like to request follow-up on any of these things, just do that now. You can click on whatever you'd like there. And let's see, if we don't get any more questions, we'll probably wrap things up because we are quickly coming to the end of the hour. Okay, I'm not seeing any other questions. So at this point, I think we'll wrap it up. I wanted to thank everyone for joining us today. I'd like to encourage everyone to kind of go to opsmx.com and check out our webinar calendar. We've got a lot of webinars that we're doing these days, due to everyone spending so much time at home, working from home. So we've got a lot of great webinars coming up. Also, some tech talks on some interesting topics coming up. So check that out at opsmx.com. Always feel free to reach out to us at on the slide, we've got hello@opsmx.com. We monitor that email address, and you can always reach out to us there. We also have a Slack channel where we provide community support. So if you have questions and anything around Spinnaker and continuous delivery, connect with us on Slack, and we'd love to talk to you there. So with that, I'm going to wrap it up. Once again, thank you for joining us, and we will hopefully see you on our next webinar. Take care, everyone.